Hello class, today we've been asked to find the difference quotient of three different functions. The first function is f of x equals 4x minus 1. The second function 3x squared minus 2x plus 1. And the third function f of x equals negative 1 over 3x plus 1. So let's start real quickly. I want to pull out some scratch paper here and talk about what is a difference quotient. This is a concept. Let my camera get in focus. It's not like in this new paper. The concept of the difference quotient is, normally we're looking for the slope of a line, and we can find the slope based on the equation or based on 2 points. So in calculus is a study of curves, and so I have a curve, and I want to know the slope of this curve. Well, the slope of this curve changes. So the way we look at it is we choose 2 points on this curve, and we draw a straight line through these 2 points, okay? And the slope of that line approximates the slope of this curve. Now, the distance on the x-axis between these 2 points we call h, okay? It's h. And as h gets smaller and smaller and smaller and smaller, this becomes more and more accurate to be the slope of this curve. Now, that's the concept behind it. And eventually, we actually come up with a formula, which is, if I say to you, find f of 2, or f of 3, or f of 5, I'm giving you an x value and I'm asking you to find the y values. Now I want you to think about this for a second. If I find the difference in y values, right? And I know the difference in x values is h. If I put this number, the difference in y, okay, or the change in y, over the change in x, so this is the change in y, and this is the change in x. If I put the change in y over the change in x, what do I find? I find slope. Okay? Well, basically, this is the same thing we do for a difference quotient. However, we make the delta x, the change in x, which we call h, get smaller and smaller and smaller and smaller. And this is the concept of a difference quotient. And so the difference quotient of a function, okay, the difference quotient of a function is, and I just abbreviate here, f of x plus h minus f of x divided by h. Now I want to go through what this means. F of x plus h means if you pick a value for x, so this value here is for x, and then I pick another value that's h units further along, then this x value would be x plus h. Okay? So we're saying take the y value when x is x plus h. That's this y value here. Subtract the y value when x is x. That's this y value right here. So subtract these two y values, and which is delta y, and divide by h, which is the difference between the x values, delta x. So this is really delta y over delta x. Okay? That's the difference quotient. Now what is the slope? The slope is the difference quotient as h approaches zero. Okay? The slope of a curve is the difference quotient as h approaches 0. So when this number here becomes so very small that it basically becomes 0, this will give you the slope of the line, or in particular, the curve. So that's why we learn difference quotients, is so we can find the slope of curves. Now, I'm just going to go ahead and tell you, if you think of the difference quotient like you think of slope, then this equation here is already in slope-intercept form, and we know the slope of this equation, right? If it's y equals, so think of this as y equals 4x minus 1, okay? Well, if this is y equals 4x minus 1, then we know the slope must be 4. Okay? We know that already. So let's see if using difference quotients we can find that. Okay? So it's a very, very simple procedure. We use the formula. I'll remind you of the formula again. Here it is. F of x plus h minus f of x over h. Okay? So basically, we're going to say f of x plus h, so it's 4x plus h minus 1 minus 4x minus 1 over h. Okay? Now what are we doing here? We're saying everywhere you have x, put x plus h. This here is f of x plus h. And then this here is f of x. Now, of course, we want to combine some like terms and get rid of some of this stuff. So I'm going to distribute here, and I'm going to distribute this negative here. And I get 4x plus 4h minus 1 minus 4x plus 1 all over h. Okay? And of course, what do we know? Well, if we say I've got 4x here, whoops, that's supposed to be an h. I've got 4x here, and I've got minus 4x here. What's going to happen? They're going to cancel. I have negative 1 here, and I have positive 1 here. What's going to happen? They're going to cancel. What do I find myself left with? I'm left with 4h over h. Well, what happens to h over h? Cancels. What am I left with? 4. So the difference quotient of this line, this is the difference quotient. The difference quotient of this function is 4, and the slope of this line is 4. And you get basically the same thing. You get the slope. Okay? So let's look at this second function here. It's a little more difficult, a little more time consuming. But again, no big deal, not something that we can't do. So let's start with our function, 3x squared minus 2x plus 1. Now, what happens? Well, we've got to write f of x plus h minus f of x over h. Okay, we have to do that. So let's write that out. What is f of x plus h? Well, everywhere you have x, you're going to put x plus h. So it's going to be 3x plus h squared minus 2x plus h plus 1. That's f of x plus h minus f of x. What is f of x? 3x squared minus 2x plus 1. And that's all going to go over h. Now, I'm going to save you some heartache and some trouble here. If we square x plus h and then we distribute the 3, we are going to get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1 minus 3x squared plus 2x minus 1 all over h. If we do that distribution and we combine all our like terms and all that fun stuff. Now, what's going to happen? Well, 3x squared here and 3x squared here, and they're opposite signs. This one's positive, this one's negative. What's going to happen? Those are going to cancel. 3x squared minus 3x squared is 0. Here I have negative 2x, and I have positive 2x, and those are going to cancel. Here I have positive 1, and I have negative 1, and those are going to cancel. And I'm going to give you a little tip here. Whenever you're finding a difference quotient, everything from the original function, everything without an h, should always cancel. So if you take your original function was 3x squared minus 2x plus 1. 3x squared minus 2x plus 1. All three of those terms should cancel out. Okay? So what are we left with? We are left with 6xh plus 3h squared minus 2h over h. Now, if we factor out an h from all three of these terms on top, what are we left with? We are left with 6x plus 3h minus 2. Okay? That is the difference quotient. Okay? That's the difference quotient. Okay? So that's how we find the difference quotient. Now, how do we find the slope of the curve? Well, if you remember, I told you that always, always, always what is going to happen is after you find the difference quotient in calculus, h will approach 0. The h value will get smaller and smaller and smaller until it reaches 0. So basically what we can say is this is going to approach 0. Therefore 3 times 0 is 0. So the slope of this curve is this equation. Now what that means is if you graph 3x squared minus 2x plus 1, if you graph that function, at any given point, the slope on that curve will be 6 times the x value minus 2. That will be the slope of that curve for any given x value that you choose. Okay? So that's how you find the difference quotient, and then to find the slope, you set h equal to 0 because it approaches 0. For the third one, we're probably not going to have room. I'm probably going to have to add a sheet of paper. We're going to find the difference quotient of negative 1 over 3x plus 1. So we'll start that off. Again, we need to write f of x plus h minus f of x over h. And then we need to come up with those values. Okay, so what is f of x plus h? Well, it's negative 1 over 3x plus 3h plus 1. Okay, minus negative 1 over 3x plus 1. So this is f of x plus h, and this is f of x, right? All over h. That is messy. Messy, messy, messy. So what do we do? Well, to combine this fraction and this fraction, we need a common denominator. Well, the easiest way to do that is to know that the LCD is going to be this denominator times that denominator. So if I multiply by 3x plus 1 over 3x plus 1 for this particular function, and then I multiply this function by 3x plus 3h plus 1 on top and bottom, that would give me a common denominator. Okay, so I end up with negative 1 times 3x plus 1 over 3x plus 1 times 3x plus 3h plus 1 minus negative 1 times 3x plus 3h plus 1 over 3x plus 1 times 3x plus 3h plus 1. Okay? And that's all over h. So now I have a common denominator, and I can combine this and this. Okay? So we do that. Well, to do that, and I'm going to need another sheet of paper, so I'm just getting that ready. To do that, we say, okay, we've got negative 3 minus 1 minus negative 3 minus 3h minus 1. So when I combine all of these things and put them together, what I'm going to end up with, and let's just see that this works out. If I distribute that negative, and by the way, when you subtract a negative, this is going to be the same as a positive. So I get negative 3x over here, and I get plus 3x over here. What's going to happen? Negative 3x and 3x will cancel. I get negative 1 over here. Negative 1 plus 1 will cancel. What am I left with on top? 3h. So I am left with 3h over 3x plus 1, 3x plus 3h plus 1 over h. Now, that's kind of an unacceptable with what I call a compound fraction, which is where you've got a fraction divided by something, and you've got basically a fraction inside of a fraction. So we need to rewrite this. So the easiest way to rewrite this will be 3h over 3x plus 1, 3x plus 3h plus 1 times 1 over h. Because basically you've got this fraction here divided by h, which is the same as times 1 over h. Well, if I multiply by 1 over h, what's going to happen to my h's? They're going to cancel. So what am I left with? I am left with 3 over 3x plus 1, 3x plus 3h plus 1. And that is my difference quotient. Okay, that is my difference quotient. So if someone asks you to find the difference quotient, that would be it. And most people get lost in the fractions. What if they ask you to find the slope? Well, to find the slope, h approaches 0. H approaches 0. And a lot of times this is written h approaches 0. It's written like that. Okay? So if h approaches 0, 3 times 0 is 0. So what do I end up with? I end up with 3 over 3x plus 1 times 3x plus 1, which we can rewrite as 3 over 3x plus 1 quantity squared. This would be the slope of the curve at any given x value. And so if you wanted to know the slope of the original problem at x equals 0 or x equals 1 or x equals 4, you could simply plug that x value into this equation, which is the difference quotient as h approaches 0, and that would give you the slope at any given x value. So I hope this has been entertaining and informative and explains why you find the difference quotient. And if you are going on to calculus, you absolutely need to know how to find difference quotients. It's a very, very simple and easy way to find the slope of a curve, or the equation for the slope of a curve, which ends up being a term called the derivative in calculus. And it's a very, very useful, simple way to do that. So if you have any questions, please let me know.